I had to redo the insulation in the steam room of our bathhouse because I wasn't satisfied with how it was originally done during construction. The re-insulation required dismantling the old benches and completely removing the wooden wall paneling. At the same time, I decided to redo the benches too since I wasn't completely satisfied with them. Then I decided to replace the stove as well. The first stove worked in a dry sauna mode, but I wanted a more humid atmosphere like in a Russian banya. I also improved how the pipe goes through the ceiling. I've already released several videos about this work on the Pesny Yashi Koshaka channel. In this video, I'll show you how to easily insulate and finish a steam room with only essential information, and how to avoid the mistakes that I made in the first version. In just 20 minutes, you'll have the knowledge to do everything right from the beginning. From bare walls to a fully finished room with convenient floating shelves, you'll be able to create your true dream sauna. So let's go through everything step by step. Hello everyone, our sauna is built from foam gas silicate blocks that are 20 centimeters thick. On two sides, there's an additional 5 centimeters of white foam plastic on the outside and a half brick facing brickwork. On the other two sides, there's also 5 centimeters of insulation and a finish with wooden blockhouse panels. From the inside, we have fairly decent, even walls. When we installed the floor tiles, we immediately built a special curb to protect the wooden finish from frequent moisture. Since there's usually a lot of moisture on the steam room floor, the left wall of the steam room is made of white silicate brick, half a brick thick. There's a shower behind it. The brick wall on the shower side is insulated with 5 centimeters of Penoplex. You shouldn't insulate the steam room from the inside with Penoplex, extruded polystyrene or foam plastic, because extruded polystyrene foam, just like foam plastic, can become dangerous at very high temperatures. Regular mineral wool isn't suitable either, because its binder releases toxins when heated. That's why, for additional insulation from the inside, I decided to use foil-faced Polyisocyanurate insulation. It's 3 centimeters thick. At first, I cut the material a bit timidly. The reason is the polyisocyanurate that polyisocyanurate boards are made of. It's a closed cell material with a fairly high degree of rigidity. Being foil-faced on both sides, it has a combustibility class of G1 that means it's a low combustibility material that can't burn on its own. I glue it on with special polyisocyanurate adhesive foam, to be continued. Polyisocyanurate boards have a chemical composition closer to polyurethane than extruded polystyrene. They withstand temperatures from -65 to 120 degrees C without losing performance. For example, the Finns have long used this advanced insulation, and they are very thoughtful people. This isn't an ad for polyisocyanurate insulation, just my personal opinion. Go to your place. I apologize for the video quality in fisheye mode. My first GoPro could only shoot this way. It will get better soon. As we can see, working with this material is not difficult at all. It was my first time using it. By the time I finished the insulation, any hesitation when cutting was gone. I'm cutting as if I've been working with Polyisocyanurate for a long time. That means it's very simple, and anyone who wants to can do it. If the boards don't fit tightly somewhere, I fill the gaps with polyisocyanurate foam. I fasten the boards to the wooden ceiling with screws. Then I use aluminum adhesive tape. Working with it is a bit different from regular tape, because the tape has a backing that needs to be removed before sticking it on. But the process still goes pretty quickly. Carefully sealing the seams won't give the bathhouse steam or scent even the slightest chance to escape where it shouldn't go. The room started to look like an industrial freezer. Near the door, part of the wall uses the frame method. I glued polyisocyanurate board pieces between the frame and added a solid outer layer. Then I use a planed bar with a cross section of 40 by 40 millimeters. I fasten the bar directly through the insulation with dowel nails. This almost completely eliminates cold bridges. I used the same bar to make embedded supports for the shelves. The lower shelf will be 50 centimeters above the floor. The top one will be 105 centimeters. The width of the lower shelf will be exactly 1 meter. The width of the upper shelf is 65 centimeters. I reinforced the horizontal supports with vertical posts. If something is suddenly unclear, pause the video and you'll be able to look at the details. I'm using store-bought aspen panels to finish the walls. The future surface quality can be significantly improved if you take the time to go over the boards with a sander and fine sandpaper. Believe me, it's worth it. After sanding, I coat the paneling with a special Sauna varnish using a roller. It's fast, comfortable, and high quality. These are real-time shots and everything moves quickly. Now the wall material is well protected from moisture exposure. I'm attaching the paneling to the battens with galvanized finish nails driven into the groove, periodically checking vertical alignment with a bubble level and making adjustments. For the ceiling guides, I use a 30 by 30 millimeter timber. It was decided to make a safe passage through the ceiling using the old-fashioned method by creating a so-called sandbox. I trimmed the insulation and added more timbers to match the level of the ceiling guide timbers. I hope everything is clear from these shots. I bought some fire-resistant minerite boards. They can be easily cut with a regular jigsaw. I'm sealing the joints with heat-resistant stove sealant. This way, the sand poured inside definitely won't find a way to escape outside. A bit of asbestos on the pipe, and I fastened the metal sheets with sealant and self-tapping screws. If the stove and pipe were installed after finishing the steam room, I could have used modern elements for passing through the ceiling, but since that's not the case, I had to do it this way. Then I used regular river sand. I pour it into the so-called sandbox. In the attic, the stainless steel pipe is surrounded by bricks resting on square profile pipes, which sit on the wooden beams of the steam room ceiling. If I were building the bathhouse now, it might have been easier to make the chimney out of a sandwich pipe, instead of building this heavy and bulky structure. Starting from about the rubber, the ceiling guides began to deviate from the horizontal, so I had to adjust the level accordingly. Polyisocyanurate boards are easy to use when the walls and ceiling are fairly even, but less convenient when they're not. I added extra embedded supports in the center of the wall for the shelves. After finishing with the paneling, the steam room size became 2 meters wide and 2 meters 65 centimeters long. The finished ceiling height is 2 meters 3 centimeters. One corner, where the door is slanted. In the places where embedded supports are installed under the paneling, I fastened the shelf board parts with thick coated screws. Now I'm moving on to building the shelves. As I mentioned before, they will have a floating effect, not steaming, but floating as in flying. At this point, I got a new camera. The fisheye effect is gone. I sawed several regimental boards lengthwise with an electric jigsaw. Now I'm drilling parts from them. To be continued. The board sawed lengthwise will be the shelf's base. The shelf rests exactly where I intended it to. The lower shelf will be exactly 1 meter wide. I made some preliminary calculations to ensure that a whole number of boards with gaps of about 8 millimeters would fit between the outer boards. So there are 9 gaps each with 7 centimeters left. 7 divided by 9 is almost 8, and that's exactly what I need. Not more, not less. With the help of a sander, I made an improvised jig out of a piece of plywood. Using the jig will make the work much faster. You can support the projects featured on the Yasha Koshak channel through the Boosty service. I'll leave the link below the video, or you can use the sponsor button on YouTube. Each board will be fastened with 2 screws, but for now, I'm only screwing in 1 screw at each intersection. At the front of the future shelf, I fasten 1 board vertically using metal brackets. It will definitely add rigidity to the front part of the structure. The back part will rest on an additional support on the wall. Since there is only 1 screw in each joint so far, the structure can wobble, and that's exactly what I need. Nothing in the world is perfect. The corners of the steam room aren't exactly 90 degrees either, and the fact that the bench can wobble a bit saved me time on making everything fit perfectly. I set equal gaps and screw in 1 self-tapping screw at each joint, all while lying in a very comfortable position. So far, everything is precise, like in a pharmacy. This bench can be lifted easily, much like a train seat. It then becomes easy to clean underneath. Everything worked out, so I'm securely fastening the parts that support the wooden piece for sitting and lying down. I don't have a circular saw, but a jigsaw with the right blade does a pretty good job replacing it for small household projects. Even if your hand isn't perfectly steady, a sander quickly fixes all the mistakes. For the shelves, I use store-bought Linden blanks. No matter how good their quality is at first, if you take the time and do a little work with a sander, you can improve their quality. Also, I go over the rounded corners with sandpaper, purely by hand. It's beautiful. Linden is Linden. I'm attaching the top shelf supports. The process is the same, but the width is already 65 centimeters. A quick test shows that the shelves can easily hold 3 people weighing about 80 kilograms each, and that's all I need. Next, I came up with a rather questionable solution so that the lower shelf would remain open during cleaning, but it works. In practice, even if you don't get it right initially, you can still remove it quickly and easily. The length of my shelves is exactly 2 meters. I ended up with a functional, well-equipped room, even if it's without any frills. You can add them anytime. I also realized I'm not fully satisfied with the dry atmosphere in the steam room from the original Sahara sauna stove. When it was fired up, the water in the samovar type tank would boil quickly, and it became uncomfortable to steam. That's why I decided to replace the stove with a more suitable one. I bought a geyser stove with a closed stone compartment. The dimensions of this stove were very similar to those of the first one, and I thought that replacing it wouldn't be too difficult. I tried to wiggle the pipe and push it up a bit, but it didn't work. With a sandwich pipe, this upgrade could have been done much faster for sure, but it is what it is. I had to use an angle grinder. The old stove was installed before the brick wall separating the steam and relaxation rooms was built. This caused some issues. The hinges and doors blocked the firebox channel, making removal difficult. The new stove has the same setup, and the channel's angle also made taking it out hard. There was nothing else to do, so I had to use power tools. What kept me going was knowing I was close to getting the perfect steam room. Damn thing won't go in. My videos now release earlier on YouTube. That's it. The size of the new food is close to the old one, but still a bit different. I had to trim the edge a little. To hide the traces of interference as much as possible, I had to make several metal parts. The old stove stood on a small pedestal. I used an angle grinder and a hammer drill to make grooves in it for the legs of the new stove. This way, I managed to lower the stove and then lift it up and slide a sheet of thick metal underneath. This way, I was able to fit the water tank pipe onto the chimney from below. Just a little bit of plaster work. I also added some fresh sand to the sandbox. I can't wait to try out the new stove. I'm pouring water into the tank. The water tank faucet was blocking the opening for adding water to the closed heater, so I had to turn it. It got even better. The faucet in the wall for adding water is now closer. All that's left is making a properly sized spout. The initial low-speed firing is underway, allowing the stove's heat-resistant paint to set and cure. I carefully wash the stones and place them in the closed heater. I put stones in the heater too. The moment of truth is close. I'm not at all against entirely wooden bathhouses made of logs or beams. It's just that in today's reality, such bathhouses have become unaffordable for many people. Very few specialists remain who can build a truly high-quality log structure. Bathhouses built with quality beams are expensive. From the start, it was clear I had achieved what I had long worked for. Dimitri, known online as the Stove Romantic, also stopped by to visit. Dimitri knows much more about bathhouses than I do.
So nothing has fallen here anymore. Yeah, Vesuvius, it's erupting.
Soon my friend sang, and I knew I had done everything right. After a considerable period of active use, I decided to look under the paneling and see how the polyisocyanurate insulation was doing, whether the foil was starting to peel off at the seams, or if mice had chewed on it. As we can see, everything works as soon as what was done yesterday is turned on, and that makes me happy.